me just start with a question we were asked on day one. Between the T1, E1 interfaces here and the patch panel, you have a SCSI cable that you need to connect between the two. The question was what length are they and what is the maximum length? So I found that it is 2 meters. That's the default length. So about 6 feet. And I've seen a possibility to order 5 meters. Right? So that's about 16 feet. And but these are of course our special orders, so we don't keep them in stock. So if you need that, you need to let us know. And if it needs to be longer than that, we will need to check if it's feasible. Now we will start with the TDM configuration. So the TDM configuration is this part here. So from the media gateway to the TDM network. So we wait, I admit someone else. It's a link between the media gateway and the TDM network here, and it can be different type of interfaces. I've shown them here, OC3, STM1, ES3, T1, or E1. So I will focus on this now, the TDM configuration part. So you see all the different interfaces I will talk about, T1, E1, DS3, OC3, STM1. Also, we talked about the bits configuration that can be used for synchronization. And then the status of these interfaces. What can we do with the status? What do we see? And synchronization. This is for synchronizing the TDM lines to the network. So if I start with the T1 configuration, there's different levels here that we see. This is the physical interface. So you saw the picture of the device with the T1s yesterday. So when you connect the T1, you can, it's a RJ48C port, and you can connect to the ports. And depending on the type of device, you will have more or less of those T1 ports. What you have to be careful is that on the physical patch panels or the rear of the devices, they start at 0. Okay, so the first one you connect will be 0. The naming convention that you use when you get a T1 in a configuration, you can change that. If you prefer starting at 1, then you could name this one the first T1 here. Okay. So this is where you connect the part, and then this is what you configure. So you need to configure a line interface. Line interface will be, in this case, of type T1. So you will have a list of the type of interface you can configure. And you will need to choose the encoding. So there's 2 modes that are supported. Most of the time it will be B8ZS, but in some cases you may want to use AMI, especially for older connections, like older CAS lines. Okay, give me a second. Someone. So the AMI for older CAS lines, but normally if you're not sure, you will choose B8ZS here, and that would work most of the time. On the line service here, we need to configure the framing. Right? So the framing, there's 3 types of framing, but only 2 that we use. One is extended super frame, and one is super frame here. Again, when it's B8ZS, we would use ESF, and if it's AMI, then we would use SF as a frame. So each one of them need to be named into the configuration. Each one need to be named in the configuration. So either you use your own naming scheme, or we came up with the naming scheme that we can use with the Metaswitch service, so that it's clear in all of the type of devices what are the naming conventions. Okay? So we can help you with that, and I will show you some of them later. The TSG800 has up to 16 T1 interfaces, and the TMG3200-TE has 64 T1 interfaces. Once you've configured those line services here, then they can be used for different types of services. H248, they call it in the H248 media gateway controller mode, they call it fixed terminations. So this is actually a TDM media channels that are available to the media gateway controller. You can assign those T1 line services to MTP2 links. So then these T1s, you will choose some of the time slots to carry SS7 MTP2 links. And you can do the same for ISDN PRI. So you can choose one of those T1 to carry a ISDN PRI that will be converted to IUA in the H248 mode. Okay, so that's the SIGTRAN relay of ISDN PRI. Okay? So this T1 can be used for these functions and also the clocking. So you may choose one of those T1 to synchronize. Okay, so it's a good idea to start with the in the full configuration of the system to start with the T1s, so that when you configure the rest of the system, all those T1s are available and you know which one you are using for your system. And here I jump to E1 because it's very, very similar. So you have all your E1 ports. Again, you can have up to 64 E1 physical parts starting at 0. Then if you want to have E1 on those ports, you can configure the line interface E1. And again, you have two modes of encoding, HDB3 or AMI. I have not seen AMI used on E1, so it should always be HDB3 in that case. Then the line service, the only thing you need to configure here is the framing. The framing has 3 modes. One is with no CRC, and in our system, it's called STD or standard. With CRC, it's called multi-frame or M-frame. But most of the time, we will use the auto mode here, and the auto mode can decide between these 2 modes which one will be used. So when the E1 is connected initially, it will negotiate with or without CRC, and then it will switch to the correct mode. If ever this auto mode does not work, then you can choose one of these 2 modes to fix the problem. Okay? But in I would say 99% of the cases, we use the auto mode and that works fine. Same as the T1s, you can support 16 E1 on the TSG 800 and 64 E1 on the TMG 3200.
Oh, sorry. Luc,
Yes?
what do you call the device with, do you have a device with maybe 4 E1s? Because, sorry to interrupt, we have a very legacy device in our network,
Correct.
called the NSG, Sangoma NSG. We are looking to replace it maybe with one of your Tmedia gateways, but I'm just now trying to get the model.
Correct. So it would be the TMG 800.
Okay.
Okay, so the TMG 800 has the same capabilities as the TMG 3200, but has 16 E1 interface. So I don't talk about this in this presentation, but it also exists.
Okay, but do you have a specific gateway with 2, let's say 4 E1s? We basically just need 4 E1s. Or are your ports licensed? Do you have a device with 4 E1s?
It's up to 16. So you can order a TMG 800 with one E1 and up to 16 E1.
Oh, okay. Thank you. Understood.
The T1 configuration. So once you've decided to go with T1, then you will go here to TDM line interfaces, choose here create new line interface, right? And then put the name of the T1. So this would be a simple naming convention. So T1-8. So you know that this device as the 8 T1 will be this one here. And then the type here, that's what you choose from T1 or E1 or other modes. The index, that's a physical index that you will connect to on the patch panel. Length is always short, and then encoding here is what I mentioned, so BHZS or AMI. Once you've created that new line interface, you need to go into that line interface and do create new child line service. All right, so the child line service here is shown at the top of that particular T1. And then you will see here, it will appear a new box. You can give it a name. So it could be the same name here, doesn't have to be a different name, but there's some naming convention I will show you later. The local index here, well, for a T1, it's always 1-to-1, so it's always going to be index 0. So the first one in that T1. So this won't change for a T1. And framing, here you have your choices of ESF or extended superframe or superframe here in the thing. Once that is done, your T1 is configured. Right? If you activate the configuration, you will have your T1 available on the system. So you see it takes only a few seconds to set that up. Once you've created your T1s, you will then have, if you click on TDM line interface configuration, you will see all the T1s in the list here. Here I've configured 8 T1s. Well, actually, there's some that are configured as E1, but you can configure all as T1. And you will have your line services, and these will always be the same here in a T1 configuration. So you can use these T1s here for MTP2 links, synchronization, and all these things. So the name that you give here is what you will see in the rest of the configuration. So it needs to be a meaningful name, right? Otherwise, it may be confusing. And here I've shown 8, but you can have up to 63 T1s or 64 T1s actually in the same system. All right. If you have a DS3 configuration, it will be slightly different because here we have 3 ports now, 3 ports of DS3 that you can connect. These 3 ports need to be configured. So when you configure the DS3, you will need to say what framing you will be using. So there's 2 types of framings that exist, M13 or M23 and CBIT. CBIT is for data. So normally we don't use this mode. We use only the M13, or I think in the configuration, it's called M23. Okay, so it's the same. Once you configure this DS3, then you need to configure the line service inside that DS3. So almost all the time it will be T1. So you can configure in that DS3 28 T1s. Each of those T1 will have a framing, and it's the same as the previous T1 configuration. So that line service T1 that will be there in the end will be in the configuration the same as if it's a T1 device. So in that DS3, so maybe this is DS3 0 here, you will have 28 T1s, so maybe T1 0 to T1 27. Okay, and these can be referenced in the configuration this way. There's a possibility to use E1s also in DS3, but I've not seen this used, so that's why I put it gray here. You can do this for the DS3 port number 1 and DS3 port number 2 here. So in total, you will get, I didn't put it here, but it's going to be 84 T1s that you will have available for the system, 28 on each of the DS3 here. In addition to the 3 DS3 ports, as you saw yesterday, you have 2 bits port on the DS3 interface. These can be also configured to receive clocking or be used as a signaling link or something like that. Okay. So the bits port here, you can configure either as T1 or E1, and then you can specify the framing that you want to use here. If you connect to a building clock source, then you'll need to have the same type of interface here. Okay, so I won't show the DS3 configuration because in the OC3 configuration, we also configured the DS3 in the example we gave. So I will move on to the OC3 configuration right away. So this is optical carrier 3. This is a SONET specification, mostly used in North America. The physical line interface, you have one OC3 connection here, which is normally a fiber connection. And if in an optional protection here, so you can have a second fiber, and then this connects to the carrier, and you can switch between the two automatically in fiber failure. Right? These fibers have a 15-kilometer reach, so it can be pretty long. In the OC3, you have different configurations you can do. If you start here, you will have 3 STS1 containers into the OC3. And in those STS1s, each one of them will have either 1 DS3, 21 VT2, or 28 VT1. Here, like I mentioned before, the E1 on OC3 is pretty rare, so I'm skipping that one. So there's mostly 2 modes that we can use for an OC3. One is having 1 DS3 per STS1, so that will give you 3 DS3s inside the OC3. Each of the DS3s will have 28 T1s like this. Okay, and the framing here will be ESF or SF, same thing as the thing. So once you finish configuring, your T1 is available to all the rest of your configuration at the same as any other modes. Alternatively, you can straight in the STS1 configure 28 VT 1.5. So that's 1.5 megabit per second that you have here. So each one of them will have 1 T1 inside. So you can configure 28 VT 1.5 with 1 T1 each. So these are the 2 modes that I see being used, either the DS3 or the VT 1.5. The bits port, we talked about that. So you have 2 bits port here. And normally when you use OC3, it would be configured as T1 here. Okay. So let me show you. And the one we will show you is the DS3 configuration here that we have done. So to configure your OC3, you can connect to TDM line interface here. Then when you are connecting initially, you can choose the type. And you saw before the type was T1 or E1. Now you have to choose OC3 here. You can give it a name. That's the high-level name of the OC3. So this will be used in the status. So you will see in the status this name appear, and you will see if it's up or down. So it can have information useful to you. Here, sometimes what I see is it says to which carrier or which interconnect point it's connecting. So then it gives you even a better view in the status of what is up or down. Then also in, for example, SNMP messages, you will see this name as well. So you'll be able to identify which interface this is in your whole network. The OC3 configuration, local index here will always be 0 because you have only one OC3 interface. The APS, that's the second port that you have, is configured just by clicking here. If you want to use APS protection, you just have to click use APS protection, and the second port will be automatically configured in the system. For DS3 interfaces, the one I won't show the configuration. You will have 3 local index, 0, 1, and 2. I need to make sure you connect to the right place on the rear of the device. Payload type here, well, it says STS3 or STS1. It's the same 3 STS1 is STS3, okay? And then loop time here can be used sometimes if there's a clocking problem at the OC3 level. So we can use this to use the remote clock for the OC3. Yeah, so I talked about this already. So this is the, let me just go back. This is a physical line interface that we configured here. So you just need to say what you want here, and it's very simple. Then when you get to the second level, so you need to, again, create new child line service. So what is underneath that OC3? And here you have the choice, right? So which one will you be using? Is it DS3, VT 1.5, or VT2? Okay, so VT2 is for E1, so we don't usually use this, but could be one or the other here. So you have the choice. If you choose DS3, you will have 3 per OC3. And if you choose VT 1.5, well, you will have 84 of those, right? Or 3 times 28 of those. Okay. So here the example is we put a DS3 configuration. So once you configure your DS3, then you need to go inside that DS3 and say, what do you want as this DS3? Normally, you will have up to 3 DS3 here, so you need to choose the local index. The framing, like I said, should always be M13 or M23, as we see here. And here there is some special configurations for detecting errors. Right? So normally these default errors are fine, but you can tune the DS3 to the opposite side to make sure that the detection rate is correct. Okay? So there's multiple choices here. It's not really explained, I think, in the web portal straight, but if we go in the DS3 specification, we get full details of what can be used here. Okay, so now we have our DS3 configured. And then for each of the DS3, we can have up to 28 T1s in those DS3. So for that particular DS3, you need to choose, well, for each of the T1s, you need to choose which framing. It could be different per T1, but normally if you're not sure, you should use the ESF framing. So this is the latest version of ESF of framing for a T1. Okay. And you will need to configure your 28 T1s here. You can do them one by one, or you can use the option that's called create multiple child line service. So then you can, if all of them are the same configuration, you can use this to create all the 28 interfaces in one command. And here you see the naming convention we have started using with Metaswitch. So you can see here, this is a line service. This is the DS3 number 1, and this is the DS1 number 1. So this is the first T1 of the first DS3 into the configuration. So, so here, let me show you what we have. So if it's OC3 and DS3 and T1s, you will see that the OC3 default name will be LIOC3, like you saw in the snapshots. The default STS1 DS3 name will be like this. Okay, so STS101, 02, 03, and DS3 01, 02, 03. So it's one DS3 per STS1 and 3 in total per OC3. Then for each of those DS3s, then you will have a naming convention like this. So for example, first DS3 and first T1, first DS3, second T1, 28 T1, and then second DS3, first T1. So when you look at the status again, you can quickly know that this is the second DS3 and the second T1. Right? So it makes it just a bit simpler. This is used in the status, and it's used also if you have an MTP tooling. It's used in the H248 fixed terminations, synchronization, so you can use all these elements here. So the same device, TMG3200 OC3 STM1 can support STM1 interfaces. So when you choose initially, you configure OC3, SONET OC3, or SDH STM1. So then it's the same. You have one STM1 main, one STM1 APS. So both of them are connected together and they work in pair. In the STM1 configuration, you can have VC4 or VC3 type of service, and I've seen both being used. In the VC4, you could have VC3 here, but like I said, sometimes we don't see these types of configuration in the systems. If you have VC4, then you will have 63 VC12 containers and 1 E1 per VC12. So this gives you 63 E1s inside the VC4. If you use VC3 here, you will have 21 VC12 and 1 E1 per VC12. So that again gives you 63 E1s inside that configuration. So for OC3, we get 84 E1s. For STM1, we get 63 E1s. But in total, it gives about the same number of channels. It's 2,000 channels in the system. The E1 configuration here is the same as what you saw before. The 2-bit port are still available. Normally, when we use STM1, we will use E1s here. So I just want to show the differences here with the OC3. So the payload type for STM1 could be VC3 or AU3 or VC4, AU4. It's the same. So you have the choice here. And you have your APS protection, which is at the bottom here. There's some settings for APS protection, but again, normally we just leave this straight and it works perfectly with those default values. If it's VC4, then you need to configure your TU12 here. So you will have 63 TU12 inside that configuration. You can see them once it's all configured. You can see them here attached to each of the E1s into the configuration. Okay, and the E1 configuration, again, there's not, oh, this is the VC12 configuration. We just need to say what is inside. And in the E1, you only need to say what is the frame. Okay. For each of these elements, you will see advanced parameters and the initial states of the system. It's very rare that we need to use this, but you can look in either on the wiki or on a real system to see these advanced parameters. In the end, what you will see when you look at the line interface list configuration, you can see your upper layer, your container, and then each of the E1s into the system. So of course, there will be a lot of E1s here, but you can see them all configured. So of course, in the TDM line interface for your situation, you will have only one of those modes to configure. If you have a snapshot of the database of this, let's say OC3 configuration that you have done, and you load it on another system, it's going to be exactly the same on that new system. The bits configuration here, you can see if you click on bits clock interfaces, it's very simple. There's only one configuration to do: create new bits clock interface, and you select the type and the line encoding here that you have. So you can quickly do your T1 or E1 configuration of the bits port. Takes you only a few seconds to do that if you plan to use your bits port. Once you have configured those TDM line interfaces, you can look at the status. Okay, so when you look at the status, you can click on those TDM line interface, and up there you have the status button as one tab, and then you will see all your line interfaces configured. So if it's OC3, you will see something like this. So the upper layer, the STS1, STS3 envelope, and then each of the DS3s and each of the T1s. So you see all the lists here. Here I put a large view, but if you put a smaller view, you can see much more. And then you have here the state. So when you see OK here, it means all the line is up and there's no major alarms in the system. However, if they are not working, then you will see something here. Instead of OK, you will see maybe loss of signal, loss of frame, remote alarm, alarm indication. So these are the type of errors you can see here. And these are only like major alarms, okay, not minor alarms. You will need to click on the specific T1 here, and then you can see all the minor alarms that occur, or if there were some counters of errors or defects. So you can go in there and see them. Okay. So when you click on that detail, you can see here information about that T1. So you see the name of the T1 here. You can see the state. Here we know it's up. But if it's down, maybe we see errors. And here you see there are some errors that occurred on the system, and you can see different types of errors that you have here. You can get more details by changing the status level here. Joshua showed you quickly yesterday. So the default mode is level 2, and then you can go to 0 to get all the details of the T1. And for example, you have CVC here, CVC. You see CVC count. If you put your mouse on the CVC, it's going to show you code violation count. So these are errors, physical errors that occur on the line. So there may be some disturbance on the line, and you will see this here. And the other ones that we see sometimes are RSP and RSN. These are slips, right? Receive slip positive, receive slip negative. So normally we see those errors when the clock is, or the system is not synchronized to the TDM on the other side. All right. So normally when we see this, it means, whoops, your clock scheme is not synchronizing correctly to the remote. So normally, if it's fully synchronized, all of these values should be 0 here. Okay. So we'll show you later how to fix that. So you see, if I just go back here, you see you have counters like this, and let's say you have fixed your clocking scheme and you want to erase those counters, put them back to 0. Then you can go here, click on reset status, and then refresh the web interface, and then remove the reset status. You will see then all the values set to back to 0. And then if there's still errors later, it's going to start increasing again. So it's just to clear out any errors, because usually when you connect the system the first time, you will produce some errors into the status, because the status will check if it's going up, down, and slips and stuff like that. So you may want to clean it up before you start operation. You saw that in the previous slide. There's an option that's called loopback here. This is used to debug the TDM line interfaces. So what you have here is the default is none, meaning that there's no loopback in the system. So it's just running normally. But you can have two different things you can do here. One is generate loss of signal. So generate loss of signal. So this is stop transmitting on that T1, or depending on what type of interface, but let's say this is a T1. So it stops transmitting. So then you can see the status on the other side of that T1, and you can see if the line becomes out of service on the other side. Right? So you can test if your T1 is connected to the right location at the remote end. You can also do a line loopback. Okay, so this is line loopback here. If you do a line loopback, all the data, the T1 data that is received, will be sent back to the destination. So the destination can see if your framing is working end to end. Okay, so you can see the data coming back. And you can also do a payload loopback. And the only difference here is that we will deframe the signal before sending them back. So there's things we can do here to debug. To try to set those debug cases, we need to select them and apply state. And as we explained on the first day, this will apply immediately. So you can go on one specific T1 here in the status, generate LOS, and immediately you will see at the other end if the line goes down. And let me just show you here what I mean by that. So for example, generate loss of signal. I have, this is, let's say, our system that we are installing now. And this is the remote system. And you have your T1, which is TX and RX going to the remote. And if you do generate loss of signal, it will stop transmitting data. And normally here we should receive a remote alarm indication, meaning that I stopped receiving data here. So I inform the other side that I'm not receiving the data. Okay, so if you are local here and you see an RAI at this end, you know that you are connected here. On this side, we should see a loss of signal for this T1. Right? So this can help you to understand or confirm that you are connected at the right place. And then you have the line loopback. So what happens is all the data that is being sent to the device on that particular T1 will be sent back. So here we can see if the data is good, if the line comes up. And so of course you won't be able to have normal operation here, but you can see if the data is coming back. So this can help you to debug the systems. For OC3, so here I showed the DS1, but for OC3, you can have the same thing. So if you click on the OC3 line, well, actually, you can click on any one of those elements to get more details. But if you click on the OC3 level, you can see here the state. You can see here there were a lot of errors. I don't see the errors specified here because I'm at level 2. So if I change to level 0, you'll be able to see what type of errors and if they're still occurring in your system. There's two options you saw in the previous slide. So again, here we can do a line loop back, or you can do a, we call it with OC3 laser off. So that means we stop transmitting. So again, this will give the same type of effect that we saw on the T1s. Right? So we loop back or we set the laser off. This is the STS1 status. So you can see the level just below. If the, I didn't talk about the path trace information, but if it's included inside, it's going to be displayed here. So you will, that's another way to know if you're connected at the right place into an optical network. And you also have the DS3 status, same type of interface. You can also do a loopback here. So you can debug your connection going down from the OC3 to the DS3 to the T1s and make sure your links are coming up. So when you debug an OC3, you will start by checking, is my OC3 up? And then is my STS1 DS3 up? And then are my T1s up? So each one of them could be different. If you have a OC3 that is down, it's worthless to start looking at other lower layer, right? So the last part we need to configure when we do TDM connections. So you need to select here your clock source. What will be your clock source? So clocking. You need to then create new external clock reference. When you do this, you will choose one of those interfaces, and it's exactly what you see here. So you can choose a OC3 STM1 interface as your clock source. You can use a BitSport, and you can also use any of the T1s or E1s in the system. Once this is set here, you can order them. to give a priority. So for example, this is a standard configuration. So your bits port are your main clock. So you put bits port 0, which goes to your main clock source of the central office. Okay, bits port 1. And then you put your STM1 as a backup. So if ever these two connections become unavailable, you still can synchronize on your OC3 envelope. And you can change the order. Just press the arrows here to change the order. And you have the status. So if you click on the status at the top here, you can see all the source of the clocks. Are they good? Okay, because they will be tested. Make sure they are, for example, if there are too much errors, it's going to be unqualified. Right? So it needs to be qualified for recovery here. And once a clock is selected, it will be shown like this, like Sonet SDH or end active like this. If you see something like this all over, this means that this device is not synchronized with the rest of the system. So it will still work. So you still have your clock running on the system, but it's not as precise as having an external clock like this. Okay, so normally we prefer to have an external clock to run the system, but it will still work. It's just sometimes you will get some slips into the system. Okay, very good. So TDM configuration is done. Did we get questions?
Yep, we got a few. Let me pull up my my list here. I think you either misspoke or misheard and accidentally said there were 64 channels on an E1. You might have been talking about 64 E1s inside of
correct. Misspoken for sure. So 64 E1 interface on TMG 3200. And what did I say exactly?
I'm not sure. Someone in chat just asked to clarify if you said there were 64 time slots inside of an E1.
Right. So it's 31 time slots inside of a T1, E1, sorry, and 24 time slot inside of a T1, to be clear.
And then there was a question about, do our devices start counting interfaces at 0 or 1?
So it's all 0. It's all 0, except that the name that you give, like we explained here in our naming convention, the first one, which is 0, we start here at 1. So it's actually the first one will be 1 inside the configuration.
If you're using our automated tool like our counter to build it up, it's going to start at 0. And I anticipated some problems there. So Luc asked me to make a quick script that'll go in after you make all these and rename them to start at 1. So if that's an inconvenience for you, just let us know. I've got a quick Python script that downloads the config, changes all the names to start at 1 and uploads it again.
Yeah, definitely that's an advantage.
Yep. And then we had a question about if Tmedia has a function where one can import an offline config template.
Import an offline configuration template. Well, yeah. So yes.
I mentioned the API.
Yeah, exactly. So we use the RESTful API to do that. It's just that we may have some example configurations that we will be building over time. But I think the best way right now is still to do a manual configuration and then download this configuration with the RESTful API tool and then re-upload it. So the answer is yes, you can have a template.
And on the, go ahead.
Yeah, sorry. Just while we're on that question, the reason why I asked is we used to, I think we still use this pattern gateway. So what we normally do with the pattern gateway is, let's say you've got an E1 or you've got a BRI, you've got an analog gateway. You basically standardize the configuration to a point whereby you basically, for an example, maybe just change the IP address, for an example, of the PBX you're connecting to. So the reason why I asked that is just thinking for the future, maybe just to standardize that, and then all you basically do is you just copy that configuration and you just dump it into the CLI, for an example. and it
Yep.
spits out the. I'm talking about something like that.
So in the patent, it's a top-down ordered configuration that goes line by line, just like a Cisco router, whereas
Okay.
ours are going to be in a JSON format. So you absolutely could get that JSON file where you've just got highlighted the line number where you need to go in and change certain IP addresses, serial numbers, and things like that. I've built a tool that uses one of those JSON config files on the back end, and then it asks you a couple questions about your gateway and goes in and fills them in for you automatically as well. So we'll talk about how to do that, and we'll take a look at the tool that I've built on the 28th. And I just wrote it pretty quickly in Python, and I would be more than happy to share that for you with any of you guys. But absolutely, when we take a look at the CLI tool to talk to the API, I'll show you how to import and export that. Since it's a CentOS system, it's not as simple as right mouse clicking like you can in a patent, and it just does the whole configuration, but it's not much more complicated either.
All right, cool. Thanks.
No problem.
Okay.
Jay asked, why would you use a VT 1.5 over a DS3 or the other way around? Does it give you the same number of T1s at the end of the day?
Correct. So it gives you the same number of T1s. It's mostly the interconnect you are doing. So what you are connecting to, if it's a MUX, maybe it's configurable, but if it's an already existing device, then you have no choice. You have to fit with what the other device has. If you don't know what it is, then you need to try both. Right. So the RESTful API can also help a lot in that. So you can push a DS3 configuration, see if it works. If it doesn't work, you can try the VT 1.5 and see that.
If you were in control of your MUX, Luc, would you have a preference between VT 1.5 or DS3?
Well, I would go with VT 1.5 just because it's just one. I feel it's one layer less than with the DS3, but
Okay.
Doesn't
All right.
matter.
And Darren had a couple questions about the SFPs, so I answered most of them. He asked, is it built-in or SFP? I said they're SFP. Then he followed up by asking they're vendor agnostic. So I also put a link in chat, guys, of our SFP module compatibility page on our wiki. And he was asking, do they come with the unit by default? Is it in a separate line item, or do we just ship everything with the SFPs?
So it's built in. It's in the same line order, and the default will be LC connectors, single mode fiber. This, and we have seen very few other models being used today, right? So initially, 20 years back, maybe it was all kinds of connectors, but today it's really this one that is being used everywhere. So if you, that's what we ship, and we don't. I think we don't even ask the question now, because it's all the same. So if it's different than this one, you need to tell us, and it comes in plugged into the device, but it's also hot swappable, so it's replaceable with another type if needed.
And on that same note, Darren was asking if you have an OC3 line up and you have APS configured, and you go into the status like you were showing and turn the laser off on your primary OC3. Will that turn the laser off on the APS and the primary, or will you be able to simulate a switch to your APS?
Let's check that when you do your demo.
I was
Joshua.
trying to jump in and check it too, but then you ended right as I was getting to the configuration page. I believe it will only turn the laser off on the primary, so it would create an APS switch on the remote end.
Okay, well, I'm not certain about that one.
I know they have different status pages, so that makes me think that the laser
Let's try.
is different, but we shall. And Patrick asks if you've tested with an old PRI from a DMS-10 with CAS signaling.
A PRI with CAS?
Using DMS-10.
Yeah, so we support ISDN primary rate, and we support CAS R1 with when we have multiple variants of CAS. So you can actually we have some scripts for CAS, so you can configure different types of interfaces. When we talk about interface with Metaswitch, then it's the Metaswitch that has those configurations, and the tones that are detected and off-hook on-hook are sent to the media gateway controller. So anything the media gateway controller will support, the TMG devices will also support.
All right. There we go. That is the end of our questions.
Okay, so maybe just do a short short demo on that. And I
Right.
need to stop sharing.
I can take over because you made me host. All right, so from our config last time, the only thing that I have changed was setting up that 1+1 group. And like we mentioned, on an out of the box unit, that's going to be done for you automatically. So I'm going to go ahead and activate this blank configuration, and everything should be good right now. It's just giving me a heads up that my web server is going to be restarted.
Yeah, so if we change the web server configuration, let's say we want to use HTTPS, or if we change the port that is being used, well, the web server is restarted, but it's only the interface to the device that is restarted, not the whole system.
Yep. If I was in the CLI commands looking at logs, none of those applications would shut down. Just the web
Correct.
server gets a quick restart. And what I'm going to be following through here as we do this, this is obviously my lab setup. We've built this site survey here, and I've got everything filled out here for my lab where we can gather things like IP interfaces, the TDM info that I'm going to need, your M2UA, because we'll eventually get to configuring the MTP2 and the M2UA. So once you have this sheet filled out, you're pretty much ready for your configuration, and you're not going to run into anything about what you don't know.
Are you showing the sheet now?
I meant to, but it looks like I messed up my share. Sorry about that.
There you go.
Let me take that over. That should be STS1 DS3 to clarify. So things for H248 configuration are here. This is my management information right here. You can see I don't have DNS set up in our lab. And then here's what we're going to be going through right now. So I really don't need to know very much information. You didn't do the clock yet. Do you want me to? Oh, you did do the clock. Never mind. So I will set up the clock as well. So we're going to go through and use some of our tools that automate that. And let's go back to our unit. So now you can see in my status page, everything is gray because pretty much everything is completely unconfigured, except my 1+1 group. It sees my backup and my secondary hosts. It sees that as well. My hardware units is orange because it's reporting that that my IP interfaces are not correctly configured, but those are going to go green as soon as we go through the next section. So I've got both hardware units, my standby and my active, are up. And both of my CentOS, the Linux boxes, are up as well. That's what it means here by host and hardware unit. This is the real-time operating system, and this is the CentOS unit. So you can see here, I've got my primary and secondary configured, and nested under this part right here, because it's on that hardware unit, it's on that telecom board, I have this TDM interface. Whereas you see this host down here, some of these configurations are more specific to the CentOS. As we mentioned before, the H248 stack runs on the CentOS. So I'm going to go into TDM line interfaces, and I'm going to be selected with something completely blank. If I was on a RJ48 unit, I would begin this by creating multiple line interfaces. But at the very top physical level of mine, which is a Sonnet SDH or STM1 OC3, I only have one physical thing to do. So I'm going to create that. I'm going to go to OC3. I'm going to give it a name, LI OC3, LI being line interface. Local index 0, which is the only option because there's only one OC3 on this unit. And then my payload type, this says STS3, but if you look at the tooltip here, it actually means 3 STS1s, just to clarify. And right now in my lab, I believe my APS is not plugged in, but I'm going to check this so that we can check the question about turning that laser off anyway. So, and then you have the revertive type of your APS and whether you're going to do bidirectional or unidirectional, meaning the switch over there, to clarify. All right, so that's done. I've got my OC3 created. It's an OC3 plus APS. And now what I need in here is some child line services. So if we refer to this picture that Luc brought up in our training, and I've already sent this link in chat when Jay asked about the VT 1.5 and the DS3, we're basically going to follow this through. So now we need to create 3 of these line services, these STS1s. So this time I am going to create multiple child line services so that I can create all 3 at once. My lab setup is set up to use DS3. This is how many I'm going to create per line interface. I want to create all 3. And then the first index to start on. So this index will be starting at 0 from our point of view, but you won't see the index number ever again once the configuration is done. Instead, you're going to see this name. And so let me zoom in a little bit here. You can see that we've got some variables to make it a little bit easier for you. You can use things like that index number or the name of the line service before it, the serial number if you have what we call the TMG 7800, which is like where you have 2 Linux systems and then a bunch of hardware boxes that are kind of like TDM cards so that you can get up to 16 OC3s. So what I'm going to do here now is I'm just going to call this LS and I'm going to name it STS1 so that I know what it is. And I'm going to put in my variable here for count. And I'm going to put a quick tag in here. And the only reason that's for is so that my script that I'll demonstrate on the last day knows how to count all these up, because this counter is going to start at 0 every time. But my script will find this, remove it, and up that. So that's what the TAG means. It literally means tag. So I've created that. It dumps me back to my OC3 interface page. But now when you go in here, you can see I've got those 3 STS1s already created. So I'm going to go into one of those. And now if we consult with our picture after the STS1, we need to create a DS3 for each. So I'm going to create multiple child line services. Again, I'm going to hold down control, and the tooltip mentions this as well so that I can select all 3. Number to create per selected line service. That's just 1 DS3 per STS1, and the index has got to start on 0. M23, T1, 3 out of 8. Oh, that's right. So I'm not sure how this is going to work if I do this, all 3 of them at once. Oh, I just need 1. Never mind.
Yeah, so you have some shortcuts up there, right, that you can use. I did explain that, but just was using
basically,
them.
it gives you the path through of what you've been making so I can navigate. The only reason I'm coming back to my OC3 is I wanted to show you guys that inside each STS1 now has been a DS3 created.
Sorry, what's that STS again? What does it stand for?
Wow, let me search for that, Joshua.
I might need to pull up my telecom dictionary there. And
Yeah,
double check
exactly.
that one. I haven't said the whole name in a minute. So, Luke, I'll keep I'll
Go
keep
ahead.
going, and
I'll
you can
search
find
for
the
that.
answer on that.
All right.
Synchronous transport signal. It's just
Synchronous.
synchronous transport signal. It's just it's like an envelope that you can put some information inside.
Oh, okay. Thank you.
So now I'm within my DS3. I can go back to my picture and I can see that I can create 7 times 4. So I can create 28 T1s here. So I'm going to do this one at a time, one meaning not one DS1 at a time, but I'm going to do it one DS3 at a time, just so I can get my naming the way that I want it. I'm going to call this LLS for a leaf line service. Call it DS301. Number to create per selected interface 28 and start on 0. And as Luke mentioned, there's super framing or extended super framing, and I don't think I've ever used SLC 96.
Sorry, will this logic apply to E1 configurations as well?
Correct. It's the same. It's just that for yeah, so you can have E1s. It's the same.
So in the E1s, generally, they're going to start in STM1 instead of an OC3. But in the theory, you could do an STS1 through an OC3, DS3 to an E1. I've never seen it, but could be done. And then basically, once you get from your carrier or your MUX, your remote connection point, what the proper framing and encapsulations are, you're just going to follow this picture, and it's a perfect flow chart of how to configure it. And I sent that link in chat for one of the questions. The question about V2 1.5 versus DS3. So there we go. We see this local index here, but this is the name we're going to see in our reporting all the time. And I've got that tag in there, like I mentioned before, just so I can up it with my script. So I'm going to go back here to my OC3. And I'm going to open both of these DS3s at the same time. So start that configuration simultaneously. I'm doing the same thing about going into multiple child line services. And in each one, you can see they're already selecting for me. I'm going to do that same naming scheme, except I'm upping that to 2, changing that to 28. And once again, I'm starting on the index of 0 because that index of 0 is relational to that DS3. Go ahead and let that start. And I will do the same thing here. Change that to 3 and change that to 28. And now, just because I don't want to overload the web server, I was watching this tab to make sure that it's completed and done before I hit create. It takes longer if you don't wait, but it's never crashed on me. It'll still work. So there we go. And our second DS3, we've got them all done nicely. And I'll go ahead and create these. All right, so there, what I have, if I take a look at my OC3, we'll see that I've got 3 STS1s with a DS3 in each of them. And if I go into one of my DS3s, I will see all of that. And now if I go to status information, I'm not going to get anything. And that is because I haven't activated my config yet. So the unit is not actually trying to bring any of these interfaces that I've created up. Nothing's being set signaling wise. And as far as the active configuration is concerned, nothing's been changed. Once I go into system and hit activate, that'll change. But we've got one more thing we want to do. I don't have bits ports plugged in, so all I'm going to do for my external system clock reference is put that whole envelope, like Luke mentioned, of my sounded SDH. So it's going to use the envelope.
What we saw is you could use any of the T1s to synchronize as well, but Normally, we prefer to have either the OC3 envelope or the bits port.
Right. So all 84 that I just made right there are there and could use them, but doesn't make much sense in this setup.
Could I ask a quick question before you leave right there?
Yeah, sure, for sure.
Okay. I hate to say this, but underneath there where it says clock reference type, I'm partially colorblind. I can't even read what's in that little white bar.
Oh,
I'm sorry. This is not the right color. I have a plugin on my Firefox to make everything dark mode. That is not
sorry.
the default. I am so sorry. I should have turned it off.
Okay. All right, good. Because I was having a difficult time. Okay, thanks, guys.
Sorry.
It's 8 p.m. for me because I'm based in Vietnam, so the lights are all off, and it gets overwhelming on my eyes. So I totally had forgotten about.
Okay,
that.
so then again, the clock ref type that we have there.
Yes, line service, bits port, and you can see the tooltips are much easier to read in this mode as well. So we've got line service, the bits port, the sonnet, and then it's asking you, is it going to be that primary or secondary of the telecom units of those hardware? That's what I've named mine for simplicity's sake. That way we don't need to keep remember any serial numbers.
But actually for Sonnet, it won't make a difference. It won't make a difference now. I don't know what happens if you choose
connected to the patch panel.
Yeah, exactly. So secondary will never be, but it could be okay for bits port. It could be different because you could have bits port connected to the primary and the secondary directly without going through the patch panel. So for bits, it could make sense. For OC2, it doesn't make sense.
Just some settings here, whether you're going to switch back to your highest priority, because if I added a bunch in here, I believe I can give an example of that because I think I can still use a line.
Yes, you could put the T1.
And like Luke was showing there, we've got the arrows here. So this would make it so that when your highest priority clock has finally qualified, it's going to bring that one online, even if the lower priority was already. And switching back from the secondary unit to the primary as soon as it's available. Anything worth talking about in here, Luke? I don't think I've ever changed them.
Nope.
Changing the qualified for delay. So like Luke mentioned in his slide, there were two states of qualified and qualified for recovery. And the difference is in the qualified, it's going to come up rather quick, whereas the qualified recovery, it's going to take a longer time to check the status and make sure that there are no errors on the line. So you might be in an environment where you need to do or want to modify those. So save everything there. My personal habit is to validate before I activate just to see if there's any hiccups, but it's not needed. When you do hit activate, it does run through the validation as well. It's just when you're on customer systems that are sometimes live, you want to be very sure that you know when you're switching and you want to do it with meaningful purpose. So there we go. Now, I don't know the state of my remote unit, but I guess we'll find out. So my OC3 has come up and you can see I was right. My APS is not plugged in. And
real quick,
but
whenever you activate it and it does validate, and if there's errors, why does it activate? Why doesn't it say stop
it
and leave the, okay.
It doesn't.
All right, because the way it sounded there, you were saying that if you activate it and it's got errors, it still goes on over is what it sounded like you all were saying.
No, it's just a best practice of I would want to fix the errors before I configure before I try to activate on a customer's box. No, it won't take a config that fails the validation. It will just leave you there. And then sometimes you might wonder, especially if I'm on a customer system where I'm looking at one specific part, but I didn't make the entire configuration. then I would want to verify that it wasn't my change that's failing the validation. Was it something the customer did? How long ago was this config activated and things like that? And it can be a long exploratory pattern down the logs. So it's just being extra safe and cautious when I'm in an environment where I don't know everything. Since I'm working support in my lab, I generally wouldn't do it because I know every change and I know every single part of the configuration.
Thank you for clarifying that.
No problem. I think I can make an example here real quick. I'll make a
No, don't go there,
Oh.
Joshua.
I was just gonna fail
We
the
can show
config.
it later because we're running out
Okay,
of
okay.
time today.
Oh, good point. Good point. All right. So there in my status, I can see that my OC3 did come up, and on both units that are plugged into the 1+1 patch panel, but my APS didn't. So let's go into my APS real quick. And let's turn the laser off and see if it affects my primary. And that should answer the question that I believe was from Darren. All right, so my laser is off. Refresh this just to be sure. So yes, to confirm, you can affect just one, whether it's your APS or whether it's your primary, to simulate that switch.
I'll try to bring the APS link up, Joshua,
Cool.
for the next days.
I think that's everything you covered, right, Luke?
Just show the clock status.
Qualified.
Click on just above. You see system clock status there.
Sure.
Yeah. You see which one is active currently.
And this should go qualified for recovery in a minute or two. So we should see that on our next section. IP interface is next, right, Luke?
Correct.
All
So
right, I'll hand
will
it back to
take
you.
control again. I lost my little. Where is it? The share screen. Okay, this one is done. This one. There you go. IP networks. So let me just go back to something here. So we configure now the TDM side. So these interfaces on this side here. Now we want to configure the IP interfaces. So these are the interfaces that are RTP, H248, M2A, etc. So all the other interface here, IP. Okay. So let me bring this up here. So I want to show physical parts, virtual parts, IP interfaces, and then the status. So you saw Joshua went through this configuration here, hardware units, and just below hardware units, that you have IP interfaces. So you can click on this here to be able to configure all those parts on the system. When you get in, you're by default into this IP interface section because this is the most used tab out of these tabs. But you can, of course, choose other elements here, and physical parts will show you the parts we saw on the installation on the first day. The virtual parts here is to configure VLAN bonding, and then the IP interfaces here are used to configure the traffic types and the IP address. The rest here is not so important, so I will go quickly over those elements in the configuration. If you go with the TMG3200, you will have 5 ports. So one of them is called MGMT0. And this one is a little bit different than the rest of the system because it's a port that is configured on the console. You use TB change IP to configure that port, and it's independent from the whole configuration of the system. So you still see it in the web portal, but it's not changeable from the web portal. You need to go on the console to be able to change them. Then you have your 2 VoIP ports here. And normally these are used for all types of traffic that you have on the system. And if you have 1+1 redundancy, you will use the 2 ETH ports to interconnect between the two devices that you have. If you have a TSG 800, the signaling gateway, there's one more port. So you have also MGMT1 that is here into the configuration. But again, you cannot change it here in the web portal. It can only see the status and see the configuration. If you and normally these physical parts are auto configured in the system, so you have nothing to do with them. The only things you can do is there's two configurations you can change. One is you can force the link down. So normally this would be to test your bonding. So when you have, let's say, VoIP 0, VoIP 1 connected together, so you can test the bonding by shutting down one of the two VoIP ports and seeing if everything is working fine. And then you can do the same on the other one. So this is for testing the link. One thing is that this is a configuration. So it's a bit different than what we saw before. You can change the status of the OC3 link live. Here it's a configuration. So when you change this parameter here, you need to apply the configuration and it will remain there until you revert the change. Okay, so it's not an apply status. And then you can disable auto negotiation, but normally that should be kept there. It's a 1 gigabit per second link. There's rarely any issues with that. Second thing you have here is the virtual ports, and these are used to create your VLANs and your bonding. Right, so the default configuration is having VoIP 0, VoIP 1, and all these ports as untagged links. But if you want to create these under other VLANs or with bonding, then you need to add new virtual ports. So you will have these ones which will be there by default into the system. Plus, if you do create new virtual port, then you can do this here. And let me just show you what it looks like. When you do create new virtual port, you can give it a name here. So this is, well, I put usually the VLAN ID here as the name, so you can recognize on which VLAN this is. Here, if you have untagged, you need to select this, but otherwise, if you don't select untagged, you need to put the VLAN ID. And then you need to say which physical parts are used. You can use only one port like VoIP 0, or you could use two parts like this. So you do like Joshua said, just press Control to keep and choose multiple options here. And once you do this, they will automatically be put into bonding. So you can, here I created one, which is a VLAN ID 100. Okay, but you can create multiple interfaces or VLANs on the system. And I think up to 32 type of interfaces here. Okay. So your physical parts, there's almost nothing to do there. Virtual parts, you create your VLANs, and then you need to create your IP interfaces. So we will define all the IP interfaces that we want on the system. So you can create them on different VLANs and with different subnets and different IPs. You can put actually on the same VLAN, different IPs. So it's pretty flexible. And you need to choose the service that will be running on those IP interfaces. And choosing the service will help you in the rest of the configuration. For example, if you have an IP interface which is used for H248, you won't be able to use it in other configurations, right? It will be limited to the menus in the different sections. So it can prevent some types of errors if you do this. But for example, you can have one link that is RTP only, and you can have one that supports RTP and SIGTRAN, and the same port could be used for the two services. The other little trick we have to be careful is that you cannot mix the H248 and management type services with the RTP and SIGTRAN services by default, right? So if you configure this here, it won't allow you to create both at the same time. However, it is possible to do that with additional configuration in the system, but it's very rare that we need this. So I'm not talking about this mode here. But let's say the basic mode is you need to keep the VoIP interfaces separate. The VoIP IP interfaces separate for H.248 and RTP. So here we can do create new IP interface here. And when we do create new IP interface, you come to this menu here. So you can give it an interface name. So it can be as simple as RTP, or you can put more information that could be useful here. Then you can select which services to use. Again, you need to press Control to choose, let's say, if the same interface will be used for RTP and SIGTRAN, you can do something like this. Then here you need to choose the virtual port. So that's what we created before. So we either an untagged port or a VLAN or a bonded interface. So you can choose which ones you want here. And here it will give you the name that you have used for the virtual port. You can use the HTTP, but that's, let's say, really rare into our environment. And normally it will be a static IP address, and you will put your information for the IP here. So you can create one for RTP, one for SIGTRAN, and one for H.248. Or you can combine RTP and SIGTRAN, or H.248 could also be used for management. Then you need to create one of those interface for H.248, one for RTP. And if your system does also a signaling gateway, you need to have your SIGTRAN IP interface. If you have only your signaling gateway, then you only need the SIGTRAN IP interface. If you use both, then you need all of them configured into the system. And that's what Joshua will show in the demo. You can have, like we explained initially, right? So you have the management 0 interface that is your default management port that you need to use to connect initially to the system. But then later you can change this. Okay, so if you want to have redundancy on the management ports, or if you want the management port to go out different VLANs, different in your network, so you can add additional management interface to your system. So you can have fixed management. So you can add a management interface called fixed management. And then this will be reachable from outside. And it will be specific to a unit. All right, so this will be specific to one unit. If you use the OAMP net option, which is this one here, then you will have a single IP to configure the whole system. So it will be a virtual IP that you will have to configure the system, or you can have one IP per system to configure the device. So this is a choice that you have to configure the system. So we went through the physical port, virtual port, and IP interfaces. Now the RTP port ranges here are automatically added. So as soon as you have an IP interface that has RTP, they will automatically create a RTP port range. Okay, the default port range will be 20,000 to 40,000. And for each call, each voice over IP call that will be created, it will use one of those UDP port range for the RTP session. So it could be 20,000 up to 40,000. So each call will have a different, will use a different RTP port. Normally, you don't need to modify this, but it's possible if you want to have a smaller range or a different range, you can go here and just change it. The ranges in a media gateway controller to media gateway interface is always chosen randomly. So the media gateway controller tells the media gateway, choose one port that you have available, and we will choose one inside this port range. Bonding here is a configuration that is done when you do the virtual part. Here it only shows the configuration. Tunnels is for PPPoE tunnels, which we don't use in this format. So if I go to the status now, so once the interfaces are configured and applied to the system, you can go and look at the status of each of those tabs here. So you can see the physical parts. You can see if they are up and what speed is negotiated. If you click on virtual parts here, you will see these are auto created. So these VLANs are just internal VLANs. So this is not something you configured. It's something that is auto configured into the system. And then you have your the ones you have created. So they will be here. Your VLANs will be here. And how many interfaces are on that specific VLAN. So you see the ones that are currently up. So if you have bonding and you see 2, it's good. If you see only 1, it means one of the 2 parts are down. Most likely, since you have those parts already in the system, you will see if one of them is down already. So it's pretty easy to figure out usually. Then in the IP interface status, what we see is now the MAC address, which have been assigned to these ports, and that can be useful when we troubleshoot. You can know from which port the messages are coming from. And you have the IP address that are configured and if they are available. And the last status you have is the bonding. So you have here bonding, active port. So let's say you have VoIP 0 and VoIP 1. You will see which one is currently active. And you can see how many times it's switched over. And this is for polling. So this is, we don't use this usually. So how many times? The bonding is only looking at the local physical ports, right? So if the link goes, if the VoIP 0 goes down, VoIP 1 will be taken up. It doesn't check if it's reaching the outside network. So if you want to add the additional protection for the switchover, you can also use the polling here. And usually we put a gateway, an IP gateway from the network to see that. But it's not, let's say it's not used very much. We use usually only the physical, local physical status. So this is what we see from the web interface, but you can also see the same if you connect to the command line. We will see some of this in the troubleshooting section, but I just want to do an overview here. So first you can SSH to the unit. So SSH with the management IP and you connect to the internal host. You have, since it's a CentOS, you can have ifconfig to see, or IPA is also the other option you have. And it can show the host interfaces. So you will see management 0, you will see the H248 interface, and we use a special internal interface to connect to the telecom unit. And you can see if that one is up as well. However, if you do ifconfig or IPA, it will not show the RTP or the SIGTRAN interfaces from the system because these are not residing on the internal host. It's residing on the telecom portion of the system. Okay. So let me show you more here. Okay. So the status. Okay, so the web portal has already a pre-configured format of all the status. So it's going to display in either tables or lists, or depending on the best way. But in all cases, you can go in status and click on browse here, and you will have the list of all the information that you can get from the system. And for example, IP interface, you can click here, /adapter/IP interface, and you will see all these interfaces that are created in the system and the data for each one of them. Okay, so instead of looking into the formatted status, you can go and get the raw information here of the system. So that's another option that we have. The same command can be done from the console, and we use the application called TB status. So you can just type TB status on the console and you will get the same information here printed out in the console of the system. Okay. Now, if we want to get telecom information, that means RTP, SIGTRAN information, we need to connect to the telecom unit. So once we connect SSH, we need to do an additional step, which is a telnet to go to the telecom unit. So the telecom unit then has different types of commands. So it's not running CentOS anymore. It's a real-time operating system we have here. And then you can do things like port list, and you can see the ETH and VoIP port plus internal interfaces here. But the ones we are interested in are the real ports going out of the system. You can do INET list to get IP address, net mask, and gateway information. So you also have here, instead of having it in the web portal, you can see the VLANs with the VLAN list command. Bonding print, you can also see which port is currently active and if the other port is up on each of the VLANs that were created. So we have all kinds of commands like this. Okay. The last thing I want to say here about the IP status is the most frequent error that we have in an IP network is we can't reach the destination. So there's two ways to test that. One is if it's an H248, let's say you want to reach the media gateway controller on H248, and you want to see if the controller is available, you can ping it. So to ping this, you do just a standard ping and the IP of the destination. If you want to make sure it's pinging from the correct interface, you can do ping-i VLAN. So this is the specific VLAN that was created for the MGC connection in this case, and the remote IP. So in this case, we make sure that it goes through the correct interface to ping the remote. Because in the configuration, when we do the H248 configuration, we will do tomorrow, we specify which interface we're going to use, and it's only going to use that interface to connect to the remote system. However, for RTP and SIGTRAN, you can't do this. If you try to ping your RTP destination or your SIGTRAN destination, this will not work because the connection is on the telecom unit. So you need to SSH first, telnet second, and then you need to use the ping command as well, but it's slightly different. As you can see here, it's ping-B, and then you need to put the local IP and the remote IP of the system. And this will let you know if that SIGTRAN destination is available and or if that RTP destination is available, or if you ping a gateway, for example, you can have this here. Okay. So this is just an overview of troubleshooting IP. We will do more of that into the troubleshooting section later. All right. So did we get any questions on this?
Just one in the chat. Patrick was asking if it's possible to change the internal IP of the hardware unit and how the CentOS communicates if needed.
It is possible to change the internal IP. The way to do this is in the initial configuration. You remember, maybe I can bring it up here. I have a snapshot here. Yes, so in the initial configuration here, when you select as a standalone unit and you do continue, I didn't show this, but you can, in between the two, you can change the VLANs and inter-unit communication, right? So it's possible to change there. But if your system is already installed, you need to do a reset host role and you go back into this configuration and change it. The internal IP normally would only be changed, and we use a very small subnet for that internal IP, and we would only need to change that if it's conflicting with your internal management network.
All right.
That's it. That's it. Did that answer the question?
I think so.
Okay.
So you'll want to do that on initial setup. It's an extra step if you do it a little bit
Yes.
later. It can still be done if you need to do it later, but it's an extra step.
Correct.
And it would be service affecting if you have that in an existing setup. Everything would go down when you reset that host role. So you want to make sure your IP scheme is known when you do your installation, and then it should be no problem. You can change it very easily.
Correct.
All right, so just to give everyone a heads up, my TDM line is green because I removed that APS that wouldn't come up. And we're going to do pretty much exactly what Luke talked about. We're going to go through and set this up in my internal system. And you can see here, I don't have that bonding tab just yet because I've got nothing bound. I can't really set up my IP interfaces.
But,
because I want
yeah,
bond
just
first.
a second, Joshua, if I can interrupt you. We just need to explain here that there's a slight difference from what the slide I showed. Go back to physical parts.
Oh, okay.
Yeah, because here you see that, yeah, exactly. So you see you have two ETH0, two ETH1, because this is a 1+1 system. It has both interfaces into the system. So it can be a bit confusing when you look at this particular system because everything is double. But when you configure the system, there are all the VoIP ports and this is a regular system, so not a 1+1. But when you do a bonding on a 1+1 system, well, it will use the VoIP 0 and VoIP 1 ports of both devices at the same time.
Configuration on 1+1, though, you configure the primary, it automatically replicates that to
Exactly.
secondary.
Exactly, and
Yep.
you will see that's what Joshua will do now. So
Yep, I'm in the primary and I haven't logged into the secondary of this lab unit in over a month. Only when I broke something one time. So physical ports, there's really not much to do here. I think Luke kind of even skipped this, but are you going to do auto negotiation for your 10/100 gigabit and full duplex, half duplex? So this really is where we want to get going. I'm going to delete these untagged on VoIP 0 and VoIP 1 because in my setup, my VoIP 1 and VoIP 0 are 100% redundant and they're plugged in to do the same function. So I don't ever need to talk with just one. And you can see here in the unit, it's primary and secondary, talking about these voice over IP ports. These are going to be used for my 1+1 to do health checks between each other. That's why they're in this VLAN 711, 710. So one host, go ahead.
How did you get them redundant like that?
yeah, we'll show you in just 1 minute. Yep.
What you're looking at right now is the default config. When I go in and create this, you'll see them redundant. I'm just about to do it.
Yeah, because all our systems are on VLANs in our lab. But if you want to use the untagged, it's fine. You can just modify the one that you have there.
So Todd is asking about, can you disable Ethernet, the ETH0 and ETH1 on
I'm
on
not
a
sure.
standalone system so that it doesn't show alarms. So I just wanted to point out on my standalone system, it knows it doesn't need these and I don't have them configured. So it marks them as down. But when I go to my status, it doesn't give me a red there.
Right.
So it's going to report that they're down, but it's not throwing massive alarms for them
Because it's
told it.
normal for a single system. Yeah.
Yeah, it's just saying they're unavailable. I don't even think they're physically plugged in. So that's all it's doing. I don't know if I have an option to actually shut these down. Doesn't look like. So,
No, it's not. It will not be in a status. If it's there, it's in the.
would it be
If it's there,
under
yeah,
physical?
it's in the configuration. Yeah, ETH0. Oh, that's IP interface. No, go back to its physical parts. Yeah, sorry.
That makes more sense. I was a bit confused by looking.
But yeah, I don't think we can change them.
Force
We
link
can.
down, maybe.
Oh, okay. I never tried that.
I'll check that and get an answer. Another one of my colleagues might be on this, so I don't want to activate
Yeah,
config
exactly.
right now. So here's where I am answering, I believe that was Conrad, but I'm not positive, question about the bonding. Nothing to do in physical ports. My virtual port is where I'm going to handle that redundancy. So I'm going to create one of my interfaces here. 0.1, and looking at my survey here. 13.
Yeah,
If I
we just
want
have
it
to make sure we
untagged, I
use,
click that and it disappears.
just have to make sure that we use the right VLAN ID for our network. Right?
Yep. And so I'm naming this VoIP because these ports are called the VoIP ports, and I'm doing _13 in my own naming conventions so that I know that it's on my VoIP ports, and it's VLAN 13.
What is that
So-
use SBC function? I saw use SBC somewhere there. What does that do? If you
Yeah,
click on
we
use
can't.
SBC.
It's
Yeah,
not
like I
gonna
said,
do
it's
anything on
no.
mine because I don't have. I think it's just me leaving the web profile of the SBC on, so that should be
yeah.
for our SBC functionality.
But,
It should
you-
be disappeared when I make.
Yeah,
the
you can't
repair.
use this in this type of system.
I think it would tell me I didn't have a license if I tried. And
So we need two different port in our configuration, right?
both of them are going out the same two physical interfaces, but they're going to be isolated by different VLANs. One's going to be for my H248 and my SIGTRAN traffic, and excuse me, yeah, one's going to be for my H248 and SIGTRAN traffic, and one's going to be for my RT. So that's done. You can see automatically they're set up to primary and secondary, everything but the management ones are. And now I'm ready to go into my IP interfaces.
Well, I want you to go to bondings first, because I think the bondings should already be there. Yes, so you
It
can
is
see here VoIP 0, VoIP 1 in that bonding.
What do I get if I click that?
Yeah, so this is what I was explaining, right? So you can create a ping instead of just right now we're relying on the local physical port being up or down, but you could do also a ping on a remote device if you want to make sure the full path is working in all cases. You can change that configuration if you want.
So that ping is actually a polling.
It's a polling ping.
Yeah. Okay.
So the remote, of course, has to reply pings, and we don't want to do this too often either, as to not disturb the network. Right? Yeah, we can do ARP.
And it looks like
ARP
you can
as
do
well.
an ARP as
ARP,
well.
yeah.
I've never.
Yeah, it's really seldom used.
So now I'm going to go into my IP interfaces. And I delete these.
Yeah, these are the default pre-configured untagged VoIP ports, right?
I'm kind of surprised it let me delete my virtual ports before I deleted that IP.
Yeah. Yeah, normally it blocks, when you try to
I thought it did too.
remove something
Delete
that is
something that's
used. Yeah.
bonded to, yeah. So IP interface, and I'm going to call this one just SIGTRAN. And now it's asking me my services here. Like Luc mentioned, there are some services that cannot be combined, like RTP and SIGTRAN are coming from the hardware unit, where H248 and Radius are coming from the CentOS. This one is just SIGTRAN.
So now we can see that SIGTRAN interface will be using this IP, And the virtual port, well, that's what we mentioned before, right? Here we put VoIP 13 because we know it's VLAN 13 and VoIP because it's using both VoIP ports. So it's quick to see that it's VLAN 13 that is being used here.
And some customers will do like VoIP 0, VoIP 1, but in my head, I know
Separate.
that if I'm naming it, VoIP means it's both of them together. If I just use one for something, I'll specify that. And as we mentioned, these names are totally customizable. It doesn't matter what you call them. This is just my own naming scheme for my own sanity. And it's asking me which virtual port I'm going to use. And my RTP is on 500. And I have no gateway on my RTP.
Right. It's
Network.
It's a local network we're using. Okay.
And then I just need one more for my H248.
Ah, yes.
So I want to point out that this is on the same subnet as the other one. And since it's two different boxes, two different IP stacks, there's really no problem with that whatsoever. I've got them both on the same subnet. They're just different IP.
Just need to use a virtual port there.
Oh.
Would you, this is going to be talking to in the case of Metaswitch, like this, the CFS or AGC.
Yes.
H248,
it's going to be talking directly to my CFS.
Yeah. So if you're doing that, would you want to have a separate VLAN so that your management of the device can't get overrun by erroneous? Would it be best practice?
Yeah, I would definitely want to keep my management isolated. You can see my management's on a completely unique IP. And I'm glad you asked that question because I wanted to point out a couple things. I can't change this from the web GUI. And you guys notice this is a brand new config you guys saw me create. The only thing I did while you weren't watching was set up the 1+1. When I activated that brand new config, my management IP did not change. It's not associated with config.
It's just shown, right? It's a read-only. You see it there, read-only.
Sorry, I misspoke when I said management. I was referring to the communications between the CFS and the TMG. So would you put that on a separate VLAN so that it wasn't intermingled within all of your actual VoIP calls? So that if you have a nefarious actor, you wouldn't have a overrunning of that communications to your CFS.
I can see why you'd want to do that. But also keep in mind they're coming from different units essentially because the IP stack on the H248, or sorry, the H248 stacks on the CentOS server. So even if you started to flood the CPU of the telco board, the H248 stack would still be up. So it does have a little bit of protection there. But I can see for especially RTP traffic and SIP traffic, there would be no SIP traffic on an H248 box. But for RTP's traffic, I could definitely see the value of keeping that in a different VLAN for protection if you're worried about that. And it's much more likely your RTP is going to go out to the public network and your H248 probably isn't. Maybe it is, but probably.
Yeah, normally it wouldn't. Yeah.
Yeah, the H248, if it goes out, it should go through a VPN tunnel for sure.
Right. I've got my SIGTRAN and my H248 on one VLAN. In my case, they are all using the same physical ports, but I do have them isolated VLAN to VLAN. And so nothing that's going to be targeted on this VLAN 500 is going to hit my CentOS box.
No. Because
there's a switch inside mediating between, and it's not going to send that. This whole VLAN will never make it to my CentOS box. So you wouldn't be able to DDoS my CentOS box from that port on VLAN 500.
Right. But you could overrun the port itself. VoIP 1, VoIP 2, VoIP 0, and VoIP 1. Sorry.
Yep. You could, the hardware unit, the telco board, the real-time operating system is so locked down on what it's listening to and what it is. I think any reasonable switcher router is going to start cutting you off before you successfully could overrun that gigabit link.
Oh, okay, cool. Thanks.
I think. Oh, I want to point out that my RTP port range was made automatically. So I can go in here and change it if I don't want to use 20,000 to 40,000. If for some reason that's out and I want to cut the last 5,000 up, no problem. I can go ahead and change that. But as soon as you assign that RTP service to one of your IP interfaces, the system creates that RTP range. And I think that's everything you went
That's
over
it.
right now, right?
Yep, that's it. So we can activate it.
Activate and check. And there we go.
Then we can check the status.
And my ports should be happy now, and they are. So there I can see my IP interfaces listed, but what was complaining before was my physical. And I guess that's because everything on those ports was untagged. And so it was getting nothing back from my switch.
And the IP interfaces there. Yeah, so this gives you a view, but it's a bit, let's say, a bit high level. But if you click on IP interface status there, you get more details.
That's a shortcut. As I mentioned before, if I go here to my IP interface, that configuration status tab that we have, if you're already looking at your IP interfaces, you can get to that same more detailed page just by hitting that status up top. There I can see some link speeds, if they're up, the IP address, and even the max. And virtual is going to tell me if both of them are up or not, the VLAN it's using, and physical. You can see the usage and make sure that you're at full duplex and gigabit. I think the only other thing you mentioned, Luke, was the browse on the status.
Yeah, but not so important right now.
Just if you need to be very meticulous and find where the reports are, here's everything you can control F and find what you're looking for.
Correct. Just show the status, IP bonding status.
Oh, I need to go into there. Oh, it retakes me to the IP interface page.
Yeah, I think it defaults to IP interfaces, but bonding here, you can say, I see now it's VoIP 1 that is active, and there has been no switch over. So yeah, that's
so
it.
we would see that change if that went down. And so our when we bond, it's not like LACP, it's active standby. When one of the ports has a problem, like with that polling interface we were talking about, or by default, it just relies on whether it has the physical connection. It'll then switch to VoIP 0, like if somebody walked by and unplugged that. And here it's counting why did it switch because physical and why did it switch because of the IP.
So we had a question here, as the Tmedia been tested with the Metaswitch IMS Volti core. So did you have a chance to talk with Metaswitch, Joshua?
I haven't. The engineer that I'm in contact with has been pretty busy. So hopefully tomorrow I will have a chance to have a discussion with him.
Okay.
And get you more answers on that, Lance. I will.